So this problem is called the chocolate problem, and it kind of got pushed a couple days. So I just want to make sure that we have enough time to complete it. So I'm just going to kind of walk you through it today. All right, so here's a real life situation where it would be important to have a limit that exists. Nina develops a recipe for caramel chocolates and provides samples of the chocolates to many of her friends, and within weeks she begins selling the caramel chocolates for $6 per pound. She offers a 20% discount to customers who buy 2 pounds or more. So here's her original pricing model. If they buy less than 2 pounds, it's $6 a pound. If they buy 2 or more pounds, they pay $4.80 a pound because the discount is 20%. So 6 times 0.8 is $4.80. And I did 0.8 because it's a 20% discount. So it's 80% of the original cost. So I want us to graph what this piecewise function would look like. So first, I'm going to plug in 0, 1, and 2 in this 6p expression. So 6 times 0 is 0. I don't know what I should count by. 7, 8. I'm going to count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is dollars, right? The cost. So if I buy 0, I pay 0. If I buy 1 pound, I pay $6. And now 2 pounds should normally cost me $12. So I'm going to do an open circle at 12 because I want to be able to draw my graph all the way over to 2 pounds. So even though at 2 pounds I start receiving the discount, this would be a straight line function 6p through the origin, slope of 6. So what happens when I buy 2 pounds? What is $4.80 times 2? $9.60. So at $2, I give them a discount and they only pay $9.60. So what about at 3 pounds? 4.8 times 3 is $14.40. 4.8 times 4 is $19.20. And 4.8 times 5 is $24. 22.24 is here. So this is also a linear function. It has slightly less steep of a slope, right? Because it's offering the discount. So what I would like you to do is use the graph and the equations to answer these 4 questions below. What do you think the cost of 1.5 pounds of chocolate is? What do you think the cost of 2.5 pounds of chocolate is? How many pounds can I buy for $20? And I'd like you to think about these 2 questions. What is the limit? I'm actually going to think about 4 and 5 with you. So pause the video first and answer questions 1, 2, and 3. And now I'm going to talk about questions 4 and 5 before we move on to the back page. So question 4, what is the limit as p approaches 1? It's approaching $6 and it's approaching $6. So from both sides, it's approaching $6. So the limit is $6. Is there a limit at 2? So this part of the limit is approaching $12, but this part of the limit is approaching $9.60. They're not approaching the same value, so that limit does not exist. And this becomes the root of the problem. So it says one day a customer explains that it costs less to buy $2 of caramel chocolates than it does to buy 1.9 pounds. Nina decides to develop a model that provides a discount but also addresses this customer's complaint. In the revised model, we've defined the value of k that will make the function continuous. So here's my same $6 a pound for less than 2 pounds. Here's my other model. I want to give them a discount, $4.80 per pound for anything over 2 pounds. What k value will shift this function up so that they both start at $12? So that way there'll be a steeper slope, and then at $12 it starts to be a less steep of a slope, but it still meets at $12. Currently, the 4.8 times 2 is $9.60. How do I make that $12? Well, don't I have to add $2.40? So K has to be $2.40. so that 9.6 plus 2.4 gives me 12. So now let's sketch what the revised function will look like. So we could still count 2, 4, 6, 8, 10, 12, 14, still 0, 0, still 1, 6, and still 2, 12. But now I can fill that circle in because at 2, this function is also equal to 12. So what is that function when I do 4.8 times 3 plus 2.4? 16.8. 16, 18, 20. So this is now 16.8. And then if I plug in 4.8 times 4 plus 2.4, I'd be at 21.6. And then if I plug in 4.8 times 5 plus 2.4, I'd be at 26.4. Wait, 22, 24, 26, okay. So it's kind of hard to see on my graph because it's not that much less steep, but here was the slope of 6, here was a little bit less steep, slope of 4.8, but they met here at 2. So I'd like you to now complete 1 through 5 down below. Now find, with this new model, what's the cost of 1.5 pounds, the cost of 2.5 pounds, how many pounds can they buy for $20, what's the limit at 1, and what's the limit of 2. And we will check off 182 the next time we are together. So please make sure to complete it. Thank you.